new live class, number 134. And today we are going to be exploring how to connect to the real Nanosaur robot, in this case using the ROS Development Studio. So yeah, let's not lose any more time and let's go for it. So hello there everybody, welcome to a new live class, and today we are going to be, as I have just said, we are going to be exploring how to connect to the real Nanosaur robot, and we are going to be working with the real Nanosaur robot again. But in the last live class we used an external computer, a local computer, in order to connect to it. So in this live class we are going to connect to it using the ROS Development Studio. I'm going to show what steps you need to follow in order to achieve that. It's very simple, you are going to see. And then we are going to connect to the real robot from the ROS Development Studio, and we are going to run an object detection node, the one that we used some live classes ago. We are going to use it on the real robot. We are going to see how this node, this object detection node, works and performs in the real Nanosaur robot. Okay? So yeah, basically that's the purpose of today's class. Let me know if everything is fine. Can you hear me properly? Sound is good? Is okay? Or not? Let me know here in the chat. I can see there we have Nabil, Gabriela Gallegos, Dennis, also Raffaello Bonghi, of course. So please let me know here if the sound is okay or clear but a bit away. Okay, let me try to put it a bit higher. Let's see if... Hello, hello. Hello there, hello there. Hello, hello. Okay, let me see. Hello, hello. Great, is it better? Better now, yeah? Better, okay. Let's see. Hello, 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 hello. All right. Hello. Okay. I guess let's put it a bit higher here as well. Hello, hello. Okay. You can, by the way, you can increase also the volume here in the stream itself. Okay, so maybe it's too low there. I don't know. Hello, okay. Hello, hello. Now it should be quite higher, right? Hello, hello, hello. Now it's good, says Gabriela. Okay, Alphonsus, Nabil, is it better? Very good. Okay, great, great then. Okay, we have it. All right, so yeah, then let's start with it. So yeah, I'm going to switch right now to my computer screen very quickly. So let me do that right now so that we can start already working, okay? So let me switch here to my computer screen. There we go. All right, so we are going to start here from the Academy. As always, you are going to find the live class here in the live classes page. Probably all of you are here right now because I can see that you are writing in the chat, so you must be here. Then today we are going to be working with a rosject again. All right, so the last live classes we weren't working with a rosject actually, but in today's class we are going to be working again with a rosject. So as always, in order to get this rosject into your workspace, to get it copied, you have to click here in the fork and open the class rosject. So that's what I'm going to do right now. Let me do it in a moment. And then this is going to basically copy the rosject to your workspace, and it's going to automatically open it also, all right? then you need to be a little bit patient in this case because this project is quite big. It's weighing 1.3 gigabytes, if I'm not wrong. So it's big, and as you can see, it's going to take some time in order to copy to the workspace and open, and etc. So open it here. Okay, I am already opening it here. Let me mute this. So, is there any audio playing now? Yes, Gustavo. There is audio. Can you hear it? Hello, hello. Can you hear me there? You should be able to hear me. As far as I can see here in the settings, audio should be working okay. Maybe you have the stream muted, Gustavo. Can you check that? Make sure that you don't have the stream muted here. So can you guys confirm that you are hearing me here in the chat? Okay, Gabriela puts here the thumbs up icon. Also, Alfonso, yes, all good. Okay, so Gustavo, then probably is that you have the audio muted. Okay, so check that. Make sure that you don't have me muted, and everything should be okay. All right, so as you can see, my rosject has already opened here. Then, yeah, so as always, I want to remind that this class, we are doing it and we are providing all these classes, these live classes related to the Nanosaur robot in collaboration with Raffaello Bonghi, who is the creator of this super nice Nanosaur robot, and he also happens to be here in the chat. He has been here lending a hand and answering questions throughout all the live classes that we have dedicated to the Nanosaur robot. So thanks a lot, Raffaello. And today, live class number 134, we are going to be showing how to switch from the simulation, from Gazebo simulation, to the real robot using the ROS Development Studio. What is the ROS Development Studio? Well, it's this environment. The environment where we are currently working on, this is the ROS Development Studio. It's an environment, an online environment, independent from the operating system, computer, etc. So it's all online and cloud-based, where you can develop your ROS projects. So in previous live classes, we have been building up upon this. So we have already completed all these live classes from the Nanosaur series, which were in the first live class, we built the simulation. In the second live class, we created a ROS2AI program for the Nanosaur robot, where we were performing some object detection. If you remember, we are going to quickly review that in today's project. Then in the third live class, we assembled the real Nanosaur robot, piece by piece. And then in the last live class, last week, we connected to the real Nanosaur robot, and we controlled it, etc. We play it a little bit with the real Nanosaur robot. So today is the fifth live class, let's say. And basically, we are going to do the same step. We are going to connect to the real Nanosaur robot. But in this case, we are going to be using the ROS Development Studio to do so. So we are going to connect directly from this environment without having to use any other system. Okay, I'm going to show you how to do that. So, yeah, let's keep advancing. By the way, let me remind you that you can find previous live classes here in the main page. If you come here to the left menu, in the workshops area, you are going to be able to find all previous live classes. Menu, in the workshops area, you are live classes here. Okay, you can see the all the Nanosaur. You can see the all the Nanosaur. I'm hearing myself. All right, so yeah, here you're going to be able to find all the live classes related to the Nanosaur series, as you can see. All right? Then, yeah, so let's keep going. So, we are going to start, in this live class, we are going to start by working with the simulation one more time. Okay, so we are going to start by launching the simulation, first of all. So in order to do this, you can come here to the how to launch the simulation section, and then here you are going to find the exact command that you need to run in order to start the Gazebo simulation. Okay, so we are going to start by, let me make this clear, we are going to start by working with the Gazebo simulation. So in order to start the Gazebo simulation, we need to open a web shell, which we can do by clicking on this icon that appears here, and, well, not really this one, but this one, the first one, okay, which is the first icon that we have here in the bottom bar, which says web shell. So we can click here, and this is going to open here a brand new web shell in our environment. So once we have the web shell, we can directly come here and copy the command from the notebook and paste it directly here to the shell, okay? So I'm going to run it, and this is going to start launching all the systems that we need in order to have the Gazebo simulation working, all right? So, so yeah, now we have this command running here, but in order to be able to actually visualize the simulation, which is this one, what we need to do is to open the Gazebo client. Then for this, we have to click in this cube-like icon that we have here. We can directly click on this icon, and this is going to open the Gazebo client, which is going to show us the simulation. As you can see here, okay? So if everything goes okay, you are going to see a Gazebo simulation like this one, where we have here, let me get a little bit closer, zoom a little bit. So here we have the Nanosaur robot on top of a desktop, okay? Since this is a very small robot, it's very, very small, then we have placed it here on top of a desktop because we think that it's something that can be interesting for this robot to move here on a desktop and so on. So yeah, you're going to have this Gazebo simulation loaded, okay? All this, what I'm doing now is basically to redo the steps that we did in live class number 131, I think it was, okay? So basically I'm redoing all that. Let me have a look here. So, yeah, so far so good. Are you following, okay, the live class? Have you started the Gazebo simulation? Any questions so far? Let's see. Is it clear? Okay, so if there are no questions, then I'm going to keep going forward, all right? So, so yeah, at this point we have loaded here the Gazebo simulation. So here you're going to find in the notebook some extra things that you can do simulation, like visualize the robot and the camera and so on with using RViz2. You can see also the topics available, both in the simulation, which are these ones. So we can open here a new web shell and run a ROS to topic list. Let me do it. And here we are going to get a list with all the topics available, as you can see. Okay, here we have them, and we have the same here for the real robot, okay? So you are going to see that there are some differences between the simulation topics and the real robot topics, okay? This is not important right now, but in a moment I'm going to come back to this, okay? So just keep it there in your minds. Then we can also run the keyboard teleoperation node, both in the simulation and in the real robot, which is slightly different, because in the simulation, the topic that we use in order to move the robot is this one, Nanosaur command bell, but in the real robot, this topic has a different name. So in the real robot, this topic is named key vel. Okay, we are going to see this also in a moment when we connect to the real robot. Then, what else? Okay, so here we have the steps in order to connect to the real robot, but before this, I'm going to move down to the section below, because I want to demonstrate the object detection demo very quickly here in the simulated robot, in Gazebo. Okay, so that we can see the demo working both in the simulation and with the real robot. Okay, this is my purpose. So you can scroll down here in the notebook until you reach this section, which says YOLO object detection. Okay, later we are going to go back to the previous section. So here in the YOLO object detection section, you have the commands that you need to run in order to start the object detection node. So we have to first source the YOLO workspace by running this command here. So let me do it right now. There we go. And second, you have to run this command, ROS to launch, darnet ros.launch.py, okay? I'm not going to go deep into these commands and the YOLO object detection and so on, because we already did that in the other live class. In the other live class, I was already explaining about all of this, how it works, etc. So I'm not going to repeat all that. Basically here, all I want to do is to run the demo and show the demo in the Gazebo simulated world environment, all right? So I'm going to copy here the second command, and I'm going to run it. Okay, so here I have the object detection node already running. So now, in order to visualize the detection and so on, I have to open the graphical tools, which I can do so by clicking on the graphical tools icon, this computer-like icon that we have down here also. So let me click here right now. And then here, I can see I have RVs here running in the background. And here I have a window, this one here, which is going to show me, it's showing me the output of the camera. So it's showing me the data that the camera of the robot is detecting right now. And it's going to also show me the detections that the robot does. So what I'm going to do basically here is to run the keyboard teleportation program. So let me go back here to the keyboard teleportation section. Here I have it, keyboard teleportation. So I'm going to copy the command here for the simulation version. I'm going to copy it and I'm going to run it here, okay? I'm working in the simulation, so I'm going to run the simulation version. Yeah, not the real robot, the simulation version. So now this node is going to allow me to move the robot, control the robot and move it by using the keyboard keys, okay? So what I'm going to do is to rotate a little bit the robot and move it around to see which detections the robot is able to do. So let me put this a little bit smaller here. Then I'm going to move this over here. So now I'm going to start rotating a little bit the robot. I'm already doing it. You can see how the camera gets updated here. It's going to get updated in a moment also here. Okay, and I can start here with the first detections. So I am starting detecting here a TV monitor, for instance. As you can see, if I keep rotating, I might detect other things. Let me try it. There I am detecting the keyboard also. Also over here I am detecting some books that are in the shelf, etc. Okay, so we already did this on the previous live class. So yeah, you can keep testing on this. For instance, if you remember, we added here some objects to the Gazebo simulation, like a banana, and we saw how the robot was able to detect the banana and so. Okay, so yeah, basically this is the first part of the live class, okay? So I just wanted to run the simulated version of the robot to recap from previous live classes. Here we have the simulated version of the robot, and here we are running the object detection node in the simulated version, okay, in Gazebo. So now in the second part of the live class, what I'm going to do is to connect to the real robot and run this demo in the real robot. Okay, so that's what we're going to do right now. Then before moving to the second segment of this live class and work with the real robot, I want to ask you, so far so good? Any questions? Yeah, is it clear, the purpose of the live class? What we are going to do? Yes, no, let me know please here in the chat so that I can keep going. All good, says Alphonsus, thanks for review, all good. Okay, perfect. Then let's go for it. So, okay, so at this point we can already close all the simulation related things. So I'm going to close everything. I'm going to close the keyboard teleoperation. I'm going to close the object detection node. And I'm going to also close the simulation, okay? In case of the simulation, it's not going to close properly, so you are going to have to close it also here from the window directly. Just click on the close button here. Let me do it. There we go. Okay, so I have closed all the nodes related to the simulation, as you can see. So now let's see what we should do in order to connect to the real robot, okay? So let's come back here to the previous section, which says connect to the real robot. Okay, so the ROS Development Studio, as you can see, it provides this icon here, which is used, this one here, which looks like a head of an Android. Yeah. So in this button, we are going to open the panel for connecting to the real robot. Okay. Then the steps to do, you have them here. I'm going to go over them right now, but you have everything explained in detail here in the notebook with images and everything. But I'm going to show the steps, which are super simple right now. So you are going to come here and open the menu. As you can see, I have already one robot available because I have configured it previous to this live class. You are going to have this empty. Okay, you are going to have this empty because probably you don't have configured any robot. In my case, I already configured the Nanosaur, my Nanosaur robot, so that's why it is appearing here. In your case, you are not going to have anything, so what you have to do is to click on this button here, which says Configure My Robot. Okay? Then, if you click on this button, this is going to open this window. And then you just have to add here a name for your robot. It can be whatever you want. My Nanosaur, for instance. Okay? You can select a name for your robot. It doesn't mind. This is only the name that is going to show here. So it doesn't have to be anything specific, only the name that you want to assign to your robot. And then you are going to select also the distribution, which it's not appearing for some reason. Here, let me see. Okay, I don't know why the data is not appearing here. Let me see. Minimize this here. Okay, so here right now for me, it's not appearing any data. I'm not sure why. Let's see. Okay, that is strange. Okay, in any case, is it appearing for you guys here, the data? Can you let me know in the chat if it's appearing for you the data or not? Let me open here the chat again. Okay, in any case, you are going to see something like this. And in this page, you should be able to detect, to select here the version of ROS that your robot is using, okay? So in our case, as you can see, I have selected ROS2 Foxy here as the version of my robot. Why? Well, because in my Nanosaur robot, in my real Nanosaur robot, I'm working with ROS2 Foxy, okay? But if your robot is working with ROS1, noetic, for instance, then you are going to have also the option to select ROS noetic over here, okay? So there must be some kind of book right now which is not showing this, but in normal circumstances it's going to show, at least with different distributions, so that you can choose the distribution that you want to, that you are going to, well, that your real robot uses, okay? So that's why in our case, I have selected here the ROS2 Foxy distribution, all right? Then at this point, you are going to be able to click here in the register button, okay? Let me see. Let me try it one more time and see if it's, yeah, no data available. So I'm not going to be able to click here myself in the register button because it's complaining about this. All right, then let me just show it here in the notebook. Okay, then at this point, you can click here in the register button, okay? And this is going to show you a page like this one, all right? So let me come here to mine. Yeah, so this is going to show you a page like this one, okay? Then here, the most important part here is this, okay? This is a script that is provided automatically, which you have to install in the real robot, okay? So what you have to do at this point is to select this and install this script in the real robot, okay? So let me show it very quickly here to you, guys. Let me come one moment here. And I would like to capture here. Okay, give me just 1 second. Let me switch to this screen here. Hello, hello. Here you have me. Okay, so I'm going to, let me show you here the real robot, by the way. I have it right here, as you can see. So, yeah, I'm going to connect here the battery to my real robot. So as you already know, once once the robot is started, we are going to see here the eyes of the robot light up or show up. So yeah, let's wait a few seconds until the robot wakes up. Sometimes right after the robot is charging, it takes some time, because while the battery is charging, you cannot start it, as you know. So as you can see, I have it also connected there to my TV, the HDMI cable. You can see now that it's actually waking up, and so. Okay, so and should be inside now. As you can see, we are already inside the robot. And as you can see also, let me point here to the eyes of the robot. As you can see, they have lighted up so that the robot is wake up. Okay, now we can start using it. Okay, so now I'm going to show again very quickly the shell. PC, grab our command here and run it. Okay? All right, so let me come back here. Yeah, so far so good. Does it make sense? I'm not seeing any comment here in the chat, which is worrying me a little bit. Yeah, does it make sense? Yes, no? With you all the way. Okay, great. Great, Alphonsus. I love that. Okay, then there is one more thing I need to comment about the shell. Sorry, about the Nanosaur robot. Okay, it's something specific about the Nanosaur robot. So let me show it very quickly by going back again to the shell. Okay, so let me come one moment here back to the shell. See, okay. All right, so we are back in the shell. Then there is one more thing that I want to show you from this robot specifically, which is that this robot, as you already know, it works with Dockers, okay? It has some Dockers running inside, which are the ones that are running ROS and so on, okay? So because of this, for this specific case, we need to do a couple of extra steps, okay? If the computer of the robot, of your own robot, is already running ROS, then nothing to worry. But if it's not directly running ROS, but it has Dockers inside, which is the case of the Nanosaur robot, then there is one extra step that we need to do, which is to modify the Docker compose file, okay? This Docker compose file, I'm going to show it to you right now. You can find it here in OPT Nanosaur. If you go inside here, you're going to see this Docker compose IML file, okay? Let me clear this so you can see it better. You're going to see this Docker compose YALM file. This is the file responsible of starting all the Dockers of the robot, okay? Then if we open this file and we have a look at the contents, we are going to need to do a couple of things, okay? First is that in the environment which is running ROS, which is this one, the core, yes? The core Docker is the one which is running ROS. Then here we are going to have to export these two variables, the RMW implementation and the Cyclone DDS URI file, okay? Here in the environment section, what we are doing basically is to set these environment variables inside the Docker. Yeah, so outside the Docker, they are already set automatically, but inside the Docker, we need to set them like this, by adding them here to the environment section of the Docker compose file. And then the second one is to add here a volume so that we have this file available inside the Docker, this Cyclone DDS XML file, which is the key for the connection, okay? So basically, what we are doing here in this volume section, in this line, the last line, which is the one that we have added, what we are doing in this line is to mount this file from the computer to the Docker image in the same path. Yeah? So if I go out of this file, and I go here inside var lib the construct RL, here we are going to see that we have this XML file. Okay? So basically what we are doing here is to mount this file into the Docker system. All right? So, for instance, if we access the Docker, the core Docker, which is this one, Nanosaur core. If we access the Docker, here we are going to see that we have the environment variables set inside here, as you can see, and also we have this file here inside the Docker. Okay? Again, these steps are necessary in the case that your robot uses Dockers inside it. Okay? If the robot doesn't use Docker, then you don't need to do anything. But if your robot uses Docker, like the Nanosaur robot does, then you need to basically do these steps so that the environment, these global variables are, let me show it again. OPT, Nanosaur, Docker Compose. You need to make these two environment variables, RMW implementation and Cyclone URI. You need to export these two variables inside the Docker container. And also you need to mount this file, the Cyclone DDS XML file, inside the Docker container. Okay, so that all this is also available inside the Docker container. This is why we have to do this extra step. Okay? All right. Then let me already get out of here. So I'm going to go back to my computer. We are not going to use the shell anymore. So just a quick recap in case. So once you have configured your robot, all you have to do is to run this script inside your robot. Yeah? You copy the script directly from here and you run it inside your robot. And that's it. If your robot uses Docker, then in that case you have to do these extra steps that I have just talked about. All right? Okay, then once we have done this, once we have completed this step, the final step is to just connect to the real robot. And that's super simple. You just come here, select the robot that you have just configured, and click on the connect button. So let me do this right now. It's going to take some seconds. Now it is connecting to the real robot, to the real Nanosaur robot. There we go. So now we are connected to the real robot. Okay? So now we should be able to open a shell, run here a ROS2 topic list, and we should be able to see the topics of the robot. Here we have them, okay? So right now I am already connected to the real Nanosaur robot. So for instance, I can run an RVS2 application here. Let me open RVS2. And here I should be able to visualize already the camera of the real Nanosaur robot, okay? So let me do a quick test here and make sure that I can actually see the camera of the real robot. So let me add here an image display and select the topic, which is image raw. And there we go. So I am already, as you can see here, I am already seeing the camera of the real robot, right? Let me make this a little bit bigger if I can. See, I can get the pixel here. There we go. Okay, so as you can see here, this is the camera already of the real robot. I'm going to put my hand here right now. Okay, so yeah, basically that's it. So right now we are already connected to the real robot. Okay, so at this point, what I'm going to do is to try to run the object detection demo in the real Nanosaur robot. Okay, let's go for that. So let me close this RVS node already, RVS2 node, and then I'm going to run the object detection demo. Okay, let me take this out. Okay, however, if we run again a ROS2 topic list, you might have noticed that the camera topic here for the real robot, it's named image raw. Okay, this is something that we can see also in the notebook here, in the difference between the ROS to topic list from the simulation and the real robot. So in the real robot, the topic for the camera is image raw. And in the simulation, the topic for the camera is RGB camera Nanosaur image raw. So they don't have the same name, okay? So I'm going to have to do something before I run the object detection node with the real robot. I'm going to need to update something, just a couple of things, in the code of the object detection node, okay? So at this point, I'm going to open the code editor here. Let me open it. By the way, I'm going to open again the chat here. I have it opened here in another computer, but let me open it again here so that I can see better any comment that you write. There we go. Let me put it here. Okay. So what we need to do? Very easy. We need to come here to the IDE, open the YOLO workspace, and inside here we need to open the darknet ROS package. Okay? Also, again, I want to repeat that the details of these packages and the files that we are going to modify right now, all this is explained in the live class 131, okay? So in case you want to get extra data about this, go back and check that live class, okay? So here we are inside the darknet ROS package, and then here we need to modify two files. The first one, we are going to find it here inside the config folder, and it's this one which is named ros.yalm. Okay? So if we open this file, we are going to see that here one of the variables that we are configuring is the topic for the camera. Then, since the topic for the camera in the real robot is named image raw, we have to remove this and just leave the topic for the real robot, which is image raw. Okay? Actually, you don't even need to modify this because I have the two options here. Yeah, so this is the option for the real robot, which we can just comment and uncomment the below, which is the option for the real robot. Okay, so we don't even need to modify anything. Just comment the first one and uncomment the second one. Okay. Then the second file that we are going to modify, it's inside the launch folder, and it's this one which is named, the only file that we have here, which is darknetros.launch.py. So let me open this file, and then here we are going to modify a couple of lines. Let me make this bigger so that you can see it. First one is here, the image variable. As you can see, here we are also defining the topic for the camera, which for the real robot we know that it's image raw, only image raw, without this RGB camera Nanosaur prefix. So what I'm going to do here again is to comment the first option and uncomment the second one. Okay? And then down here again we have the same. We are defining again the topic name for the camera. So I'm going to comment this one and uncomment this one, which is image raw only. Okay? And that's it. That's all. Okay? So basically what I have done here is to set the topics for the camera that the real robot uses, not the ones that the simulation uses, because they are different. Do you understand why I am doing this here? Does it make sense why I am doing this change? I am setting the topic name that the real robot uses for the camera. Yeah? Do you understand, guys, why I am doing these modifications here? Does it make sense? Yes? No? Clear? Say, okay. Perfect. Then let's go back to the shell. Let's go back here to the shell. And then what should I do now? Well, there is one thing that I need to do, which is to compile again my workspace, okay? Since I have done some modifications here, I'm going to recompile everything, call combuild. So I'm going to recompile my object detection node so that it gets the new variables. There we go. And that's it. So now I am ready to run the object detection node. So let me come back here to the object detection section, and I am going to run this command, okay? It's the same command that we used for the simulation. It's exactly the same command. So I'm going to come here and run this command. There we go. Okay, so now I am already running the object detection node. So let's have a look. What do you think, guys? Let's have a look, right? So let me come here. Give me just 1 second. All right, so let's open here the graphical tools. And there we go. So here we have already the object detection node for the real robot. As you can see, it's already detecting my fingers, and it's marking them as a person, okay? Probably we can try to get a bit closer my laptop computer that I have here. Yeah, and it was already detecting it as a TV monitor. Let me get out of here and see if it detects it. Not really. Maybe if I get the computer here closer, let's see if it's able to detect it as a laptop. Let's see. Not really. Okay, so let's do one thing. Instead of putting objects here in front of the robot and see if it detects them, what I'm going to do is to move the robot, right? I'm going to move the real robot and see what it is able to detect. Okay, let me put this back here. Okay, so let's come here and let's run the keyboard teleoperation program in the real robot. So I'm going to come back here to the keyboard teleoperation section. Here you have it, and then I'm going to run the command, in this case, which is under the real robot section. Okay, so let me copy the command from here. I'm going to open here a new shell and run the keyboard teleoperation program for the real robot. Okay, so now I am going to be able to control from here, from my keyboard, the real robot and move it. Okay, so let's get back here. All right, so let's open this again. Okay, here we can see that it was kind of detecting the TV monitor. All right, then let's keep this opened, and then from here we are going to start moving a little bit the robot and rotating it in order to get different images from the camera, yeah, different points of view. So let me start trying this. Okay, so I am already, yeah, as you can see there, it's funny, it was detecting a bed for a moment, so a sofa now. Okay, so let's rotate a little bit the robot. I am now rotating it, as you can see. It's detecting the laptop. I am still rotating it. Here, now this is a Mac, okay? But from this perspective, which is super close, it's hard to detect, right? So what I'm going, well, it was actually kind of detecting it, but if we get a little bit far away from the Mac, probably it's going to detect it better. So that's what I'm doing right now. I'm getting a little bit far away. Okay, also the camera also, it's pointing way down. So let me, because my head was down, there we go. I have placed it now the head properly. And as you can see now, it's properly detecting the cup, okay? It's also detecting some persons here, which are not persons. These are just wires that I have here. The problem here from my environment is that everything is full of cables and things around. So that's also adding noise to the object detection node. But yeah, let me keep moving a little bit around the table here. Here I have a keyboard, which, as you can see, it is able to detect very well. So here I'm detecting the keyboard. And right behind the robot also I have a mouse. So let me rotate it here so that, let's see if the robot is able of detecting the mouse. Okay, now I am pointing here to the mouse. Okay, let me rotate a bit more to get a better angle. Let's see. Okay. Not quite. It's not quite detecting the mouse. I don't know why. It should, since it has a clear view. Okay, there it goes, yeah. Maybe I am too close to the mouse, I don't know. Or too far away. Let me get a bit closer to the mouse. No, probably I should get a bit far away from the mouse. Yeah, so if I get a little bit far away, it detects things way better, as you can see. So yeah, basically that's it. So as you can see, let me very quickly switch here to my real scenario so that you can see what's going on here, and you can see that I am actually controlling the real robot. Yeah, so here I have the robot with the mouse. Down here I have my Mac. So you can see very clearly here that I am controlling the real robot, right? I'm moving it around, and yeah, all of this, I am doing it here through the ROS Development Studio. Okay. Yeah, so Gabriela was suggesting to change the angle a bit. So at the end, it was that it was too close to the mouse, so that's why it was not able to detect it. Let me put it here with the cup. Let's leave it here. All right, so yeah, basically that's it. Basically that's it. I hope that you have liked this demo. Let me know your thoughts. So yeah, here we are running object detection with the real robot. Okay, so as you can see, we have been able to perform it with the simulation, but also now we are being able to run it from the real robot. Okay, and as you can see, it works pretty well. Okay, so it has some errors, of course. Also, I have lots of things here in the table, which it is adding some noise. But when it has a clear view of an object, actually, as you can see right now, it's able to detect it pretty well. Yeah. So many thanks for an informative session. Is all code on the robot? Alphonsus, no. So in the robot, what I have is ROS installed, okay? Basically in the robot, what we have here is ROS installed. All the code that I am running, so for instance, all the object detection node, it's not in the robot. The object detection node is here. It's in this rosject. Okay, here you have all the code that I am running for the object detection node. It's all here. It's in the rosject. Yeah, so it's not inside the robot. But we are connecting from the environment, from here, we are connecting to the real robot, and we are running these programs which are here. Okay, but they are not inside the robot. Inside the robot, we only have ROS installed and NVIDIA, some drivers, and so on. Yeah, does this answer your question? Alphonsus? Faster image processing is faster decision. Absolutely. Absolutely, Alphonsus, yeah. So, Yeah, so we could also, of course, we could install all this code inside the robot, of course, and run it with the Jetson Nano and so on. That's perfectly possible, okay? So don't misunderstand me. I'm not saying that it can be done. This is just the setup that we are doing here, okay? In this case, we are running the object detection node here. But of course, it's possible to run it inside the Jetson Nano. In fact, probably in this case, it would be better, because we would have GPU capabilities, and all the image processing, as Alfonso is saying, would be faster, okay? So you can try that, of course. If you have your own Nanosaur robot, you can try to put this code inside the Nanosaur robot and run it from there. This is something that you can try by your own as a project. I encourage you to try it, okay? So yeah, I'm going to leave it here. I'm going to leave it here. All clear, and thanks again to both of you. This was great. Thank you. Thank to you, Ryan. Thank you. So yeah, I'm going to leave it here. Thank you very much for being here with me in this live class. In theory, this is going to end the Nanosaur series, okay? Not 100% confirmed, but probably we are going to end the Nanosaur series here. In any case, I'm going to see all of you next Tuesday with the next live class. I hope you have enjoyed all these Nanosaur series. I think that they have been very nice and very informative. Also, they have been new to us. It's the first time that we do this kind of series with different live classes of one same thing, and covering so many different things. So working with simulation, then building a real robot, then connecting to the real robot and doing things with the real robot. We really enjoyed this series, and I hope that you have enjoyed them also. So yeah, hopefully we are going to have more series like this in the future. So yeah, thank you very much for being here with me. I will see you in the next live class, and until then, as always, keep pushing your ROS learning. Bye-bye.